Hello everybody, it is the Bearded Tangent, and today we're going to look at graphing sine and cosine functions. So the problem we're going to be looking at is graphing a sine function from negative 5 pi to negative 3 pi. So before we can get to that, we're going to look at our sine function. We're going to fill out a t-chart on it where it's going to be at certain spots, and we are going to graph it from negative 2 pi to positive 2 pi so that we can get an idea of how the function works, notice patterns in what our function is doing, and then use those patterns to solve the problem over here. Okay. If you have a unit circle handy, we'll be pulling everything from the unit circle, so it's really quick and easy to use if you have that. Otherwise, you'll have to kind of memorize this as you go. All right. So the sine function is, of course, opposite over hypotenuse, and we can graph this on our standard xy coordinate plane. What we'll be looking at is the unit circle and looking at our quadrants. Now you can look at like 30 degrees and 60 degrees and 45 degrees as well. However, our quadrants are going to be where it's at some definitive points like 0, 1, and negative 1, and they're easy points to graph. So those are what we'll be focusing on today. We're also going to be looking at them in radians. So instead of doing 90, 180, or 270, you're going to see pi over 2, pi, 3 pi over 2, and the like. So don't let that throw you. That's how we use this to graph. Okay. So the first thing we're going to do is we're going to start with 0 and find out where sine is 0. Now on your unit circle, you know that the y-coordinate of any point on the unit circle is the sine coordinate due to the unit circle having a radius of 1. So if you go to 0 on your unit circle and you look at the y-coordinate, you would see that sine is 0. Okay, and then we'll just work our way around. So if we go to pi over 2, which would be 90 degrees, we would see that sine equals 1. If we go to 180 degrees, which would be pi, we would see that sine once again equals 0. If we go to 3 pi over 2, which would be 270 degrees, we would see that pi equals negative 1. And then if we went to 2 pi, we would see that sine is back at 0. Okay. Now, this is a very small snapshot between 0 and 2 pi. If we just looked at half of our graph here, it would be very difficult to get a full idea of what our sine function is doing. We'd only be seeing one period of the sine function. So we're going to look at 0 to negative 2 pi as well so that we can get a bigger picture of the overall function. So we already know that 0 equals 0 on our sine function. All right. Now, to do these negative values, we're going to start at 0 degrees and we're going to start going clockwise instead of counterclockwise. So negative pi over 2 would be negative 90 degrees. This is going to be the same thing as positive 3 pi over 2. If you went negative 90 degrees on your unit circle, it would be the same thing as if you went 270 degrees positive. So that means negative pi over 2 is going to be negative 1. Negative 180 would be the same thing as positive 180, so negative pi is the same thing as positive pi. So we're going to get a 0 here. Negative 3 pi over 2, that would be negative 270 degrees. That would be the same thing as going 90 degrees counterclockwise positive. So we're going to get a 1 here. And then negative 2 pi would be the same thing as positive 2 pi would be the same thing as 0. So you're going to have a 0 there as well. Now, since we have these points, we can take them and we can graph our sine function. So I'm going to start here at 0. I know that at 0 my sine function is 0, so we're going to put a dot here. I know that at pi over 2 it equals 1, so we'll put a dot up here at 1. I know that at pi it equals 0, so we'll put a dot back here on the x-axis. At 3 pi over 2 we're down at negative 1. And then at 2 pi we're back at 0. So now we want to graph our negative side. So negative pi over 2, I'm going to be back down at negative 1. At negative pi, I'll be back up at 0. At negative 3 pi over 2, I'll be at positive 1. And at negative 2 pi, I'll be back at my x-axis. Okay. So this graph is going to be rounded, so you're not drawing straight lines through these points. And so if we draw our sine graph, it's going to look something like this. Okay, so rounded points going up and down. The key takeaway here to differentiate this from a cosine graph, which I'll put a video up for next, is that our sine graph is at 0 here for the parent function. The parent function is y equals sine of x. Later, when we get to where we are shifting these graphs left to right, that might not necessarily be the case, but the sine parent function starts at 0. Okay, and there's a lot of information we can glean from this graph. We can see where it's hitting the x-axis, where it's at its minimums and its maximums, that it has a period of 2 pi, that is, there's 2 pi before this graph starts repeating. Now this graph goes on forever on my negative x-axis and forever on my positive x-axis. We can keep going around the unit circle, never ending, okay? However, it does only go from 1 to -1 on my y-axis. So how can we use this to graph this portion here? All right, so we only go back to -2 pi. Here I'm wanting to look at from -5 pi to -3 pi. Well, there's a bit of information we can pull from this, some patterns that we can see that will help us graph it between -5 pi and -3 pi. So the first thing I'll go ahead and do is draw out a x and y axis for this. Since we don't have any positive values, I'm not going to worry about drawing any positive axis. So it's only going to go from 1 to -1. This midline would be 0. All right, I'm going to put my little jagged line letting me know that I'm skipping a little bit forward because we're not actually starting at 0. -3 pi is where we are going to be ending this at, and then we'll be out here at -5 pi at the very end. All right, so I want to put a halfway point between these two. So halfway between 5 and 3 on this would be -4 pi. All right, and then I'm going to put halfway points between those, because just like here, from 0 to 2 pi, I have a halfway mark, and I have 2 quarter marks. I need these 2 quarter marks. Now, you may want to label these, you may not, as long as you understand that they're halfway between -4 and -5. It may not be necessary to label them. This would be -9 pi over 2, and this would be -7 pi over 2 if you did want to label them. I'm not going to label them today just for the sake of saving a little bit of space as things are getting kind of crowded. All right, so we need to determine where our points are going to be on this graph. So where my points going to be on the axis, where will they be at the maximum up at 1, where will they be at the minimum down at -1. Okay, so it's going to take looking at our original graph and then moving the stuff over. So if I look at my original graph, let's first look and see where my points are at the x-axis, at the 0 line. So I see at 0 it's there, at 1 pi it's there, at 2 pi it's there, at -pi, at -2 pi. So anytime I am at a integer in pi, I am on the x-axis. And remember, an integer is any whole, positive, or negative number. So I can take this information and come up here and say, well, at -3 pi, we'd also be at 0. At -4 pi, we'll also be at 0. And -5 pi, we're also going to be at 0. And this will be true for any sine parent graph that we have not changed the period for. Okay? So now we just need to determine on these 2 quarter marks which one of these will be up at my maximum at 1 and which one will be down at my minimum at -1. So again, we can use a trend. So let's look at the negative portion of my graph down here. So we just want to look from 0 back to -2. All right. Whenever we get to -pi, this is an odd number, -1 pi, we are moving upward from that point on. When we hit -2 pi, an even number, we are moving downward. So I can look at this graph and see if it's a negative number, a negative odd number, we'll be moving downward. If it's a negative even, if we are at a negative odd number, we will be moving upward. If we are at a negative even number, we will be moving downward. So from that information, I could see that at -3, we would be moving upward. And so between these 2 points at -7 pi over 2, we will be at +1. As we pass through -4 pi, much like if we were passing through -2 pi, we would be moving downward. So here at -9 pi over 2, we would be at the minimum at -1. So if we graph this between these 2 points, our graph would look like this. Okay. So using our parent function and our original graph between -2 pi and +2 pi, we were able to graph our sine function between -5 pi and -3 pi just by noticing some of the trends and the patterns that the graph has. And you can do the same thing for the cosine graph, as we'll see in the next video. So thank you guys for watching. We'll catch you next time.